In this video, I will review how to perform a z-test. Let me review the example. The example states the following. The American Association of Community Colleges states that the average cost to attend a community college is $3,350 per year. An institutional researcher at a community college in Southern California believes that the cost to attend a community college is lower for this region. She surveys 30 students and finds that the sample mean cost in Southern California is $2,800 per year. The population standard deviation is 650. Tests the researchers claim. Alpha is 0.05. First of all, we examine the fact that we are given the population standard deviation. This lets us know that we can perform the z-test to test the hypotheses. Our next step is we have to state the claim, determine H naught and H sub 1. The claim is that the mean for community colleges in Southern California is less than the average stated by the American Association of Community Colleges. So the claim is that mu is less than 3,350. That is the claim. Since we have a less than symbol, it's also an H sub 1 statement. The H naught statement always has the equal sign. It is mu equal to 3,350. Since we're performing a z-test, we draw the standard normal distribution and we examine H sub 1. Mu is less than. Think of the inequality as an arrow. It's pointing to the left. Thus, we have a left-tailed test. So we draw and shade in a left tail. Our next step is to find the critical value. So we could use table F to find the critical value. I would strongly recommend using table F. So let's take a look at table F. In table F, we ignore the confidence intervals and determine if we have one or two tails. We have one tail. The next step is we have to locate alpha. Alpha was 0.05, so we scroll down to the z values. The z values are located in the very last row. Ignore all the other values. Those are t values. So it is 1.65. And since it's to the left of 0, we make it negative 1.65. So my recommendation is to always try to use table F first. You'll rapidly determine the z value, which is our critical value. Now, in some cases, we have to use table E. In this situation, we have to set our area equal to alpha. And alpha is 0.05. So this tail area is equal to 0.05. It is a one-tail test. We look up the area of 0.05 in table E. And remember, we have to look inside of the area section, and it so happens that 0.0495 is as close as we will get to 0.05, and we look to the left, negative 1.6. We look up 0.05, thus we have the critical value. It's negative 1.65. And the critical value separates the shaded region, which is known as the critical region, from the unshaded region, which is known as the the non-critical region. So remember, we have two processes that we can use. Table F is the easier method. Table E will work in all cases, but it's a little bit more involved in terms of finding the critical value. Our next step is we have to compute the test point. So the test point formula is Z equal to the sample mean minus the population mean divided by the standard error, which is sigma over radical n. We take our information from the problem, plug it into the formula. Sample mean is 2800, population mean 3350, standard deviation is 650, and n is 30. Let's go ahead and perform the calculation using a calculator. So we have 2800. I always begin by entering the parentheses minus 3350, close the parentheses, divided by, and then we type in the standard error. Of course, I use parentheses to encase the standard error, just refreshing my memory. It's 650 divided by the square root of 30. So you type in 650 divided by the square root of 30, close the parentheses and select enter. And we end up with negative 4.63. This is our test point. So we use the test point to determine whether the test point falls in the critical region or the non-critical region. While negative 4.63 is compared to the critical value, it is to the left of the critical value. It is a smaller number than negative 1.65. This means that the test point falls in the critical region. If it falls in the critical region, we reject H naught. So remember, the z-test is always used to determine whether we reject or not reject H naught. In this case, H naught is rejected. Now, what type of impact does that have on our claim? Let's find out. Because the very last step is we have to write a summary of our findings. And there is a nifty flowchart that can help us determine what is the proper summary to write down. While the claim, if you recall, is H sub 1, and we rejected H naught, thus the statement we write down is that there is enough evidence to support the claim. And that would be the final step in our process. There is enough evidence to support the claim. Thank you for watching the video.